Okay, so we're looking at this free body diagram. So in order for us to figure out the vertical or the y component of the forces, okay, we need to incorporate the FA of y. Okay, so here you're gonna have to add those two because they're both moving upwards, right? So there is really no vertical motion here. There is no vertical motion, so that means the net force on the y is 0. Okay, so we know that the Fn plus the Fay, see these two forces going up, must have been balanced by the force going down, which is, what's the force? Gravity. So those two must be equal because the net force is 0. Here's the full formula. Net force on y is equal to Fn Fay minus Fg equals 0. There's a full formula. So we can just equate the two. So far so good? Okay. So from here you see Fn plus Fay equals Fg. This is where we're at. So we need to now isolate Fn. Fn is equal to Fg minus Fa of y. Okay. So this is the only thing that we know is mass. Let me see here. Let's pull out the known variable. 1 times 10 to the power of 2 kilogram. We know that the angle is 30. Okay. 30 degrees. And the mu is given at 0.2. Okay, so those are the only things that we know here. Can we calculate the frictional force now? Well, frictional force is mu F of n, right? But in order to find the F of n, we need to go Fg, which we have the mass m times g, but we don't have the applied force, right? So we're gonna have to split this into x and y components again. Okay, so we're gonna have to find something in common for this. Okay, so x and y. What are the forces on the x, the horizontal? So we got Fax equals frictional force because the acceleration is 0. Net force is 0 here, it says. Okay, and on the vertical component, we already wrote that down. We got Fn equals Fg minus Fay. Okay. All right, so let's now simplify this. Okay, let's simplify. Let's expand on the Ax. How do we find the Fax? This line right here. Look at that. So we have the hypotenuse. We're looking for adjacent. Yeah, so this is going to be Fa cos of 30 equals frictional force, right? And frictional force is mu F of n. Okay, so you see here F of n is Fg minus Fay. We're going to substitute that into here. Kind of like that, yeah. All forces work the same. So now we have Fa cos 30 equals mu. Now we gotta put in Fg minus Fay. All right, let's actually expand on the Fay first. What's Fay? Fa sine of 30, right? Okay, so let's actually do that. Fa cos 30 equals mu Fg. I'm gonna put mu mg, right? Fg is mg, is that okay? Minus mu Fa sine of 30. Is that okay? Sounds okay so far? I just put this in, clear the brackets. So this becomes mu Fg minus mu Fay. So I just expanded it. So far so good? Okay, so what do we not know? What can we find now? We can find the Fa. We can solve for the Fa now. Okay, so we have cos of 30. You guys can calculate. Somebody, you guys all do this. Get your calculator and give me, actually, let's do this first. Let's put together the Fa. I'm going to do this, okay? So FA cos of 30 degrees. This will become plus mu FA sine of 30 degrees equals mu mg. Okay? Now I gotta get that mu out somehow. Okay, I was gonna simplify this at first, but I think at this point we are just gonna put in the numbers. Okay, so I'm gonna go FA. What's cosine of 30? 0.866. So we have 8.866 FA. Is that okay? Okay, you guys have to do this with me. Plus, you have the mu. Okay, so let's enter that. So 0.2, okay, times sine of 30, which is 0.5. Are you with me? Is equal to 0.1, okay, plus 0.1 FA is equal to, let's come up with a number for this. So 0.2 times 1 exponent 2 times 9.8 equals 196. Yes? Okay. So now what's 0.866 plus 0.1? 0.966 FA equals 196. Now we need to find the FA. So 196 divided by 0.966 is equal to 203 Newton. That is the applied force that you need to apply.
So, okay, the question said to be what is the magnitude of F? So how can it force of apply?
Yeah, we're looking for the magnitude of the force that you need to apply so that the forces are balanced. So that the kinetic frictional force and the forward force here is equal. So that's what we did here. We set the net force to be 0 in both the horizontal and the vertical component, okay? And we worked it out separately into the x and y component. Okay, so if you set the net force to be 0, then the work done by the forward and the backwards forces will be equal to 0 as well. It's almost like if I've got Adam here and I'm pulling Adam and Michael behind him is pulling him as well. Okay, so I'm looking now at how much force do I need to apply on Adam so then I can pull him with his arm up angled at 30 degrees. So that's what we did here.